Recording in progress.
Okay, welcome to ITS 454. So today, this is the second week. Today is Tuesday, so we're going to do a lecture. Now, this course is a very problem-focused course. Okay, there isn't really that much theory, if you will. So it's very applied. So I'm just really not going to be going through PowerPoints a lot. Make sure though, whenever we're in a module in Brightspace, that you always check out all the materials. Okay, so definitely, I may have some slides, so read them. So I may sometimes just say the things that are in the slide, so they're for your own help. Okay, so let's switch over to Brightspace, which means I need to share. So you should be seeing now Brightspace, okay? All right, so we're gonna go ahead. This is 454.001. Okay. And we're gonna go to content. Okay, so last week we started with scapy. So I believe I did some examples of how scapy works. I went over, provided a link to the scapy website where you can find more information. We went over this document of fun things that you can do with scapy. And then you have a case, the Ph.D. case that you're working on, which is going to be due on Thursday. And actually, it should be interesting for you to practice scapy and trying to solve the problem, or So that's last week. Let me minimize this one. This week, let's open up the module. This is the module for this week. So it's basically before we start getting into like attacks or defenses, we're just going to take a look in general what's the underlying concept between it, or the common theme, I guess, or common, common things between attacks and defense. And really that's usually called sniffing and spoofing. Those are the two terms, and basically they relate to dealing with packets. So as this class is about network security, at the end of the day, the focus is on analyzing, the data that would be relevant to network security. And in that case, that would be packets, right? So if, whether you're dealing with a firewall and you're just going to configure the commands for it, as we will see later on with IP tables and hopefully with the Cisco equipment in the lab, you're still, whatever you're doing on the firewall, et cetera, for adding commands, you're basically taking a packet every time, and you're going to break up the packet into the headers and extract information from the fields. And then once you have that information, you're going to make decisions with it, right? Such as in a firewall, you're going to say, okay, this IP range or this IP or this protocol should be dropped or should be let go, or maybe we're going to log it or something along those lines. So at the end of the day, if you think about it, cybersecurity boils down to information, data, right, in some format, in this case, the network, because we're not looking at malware, for instance, or we're not looking at cryptography, or we're not looking at phishing, or whatever you want to think of, binaries and reversing the binaries, etc. We're looking at some data. So in this case, network. So this is a specific type of attacks and defenses that are all related to a packet and its structure and how it works. Okay. So anyways, so sniffing and spoofing, the way that I'm going to describe sniffing and spoofing, the way that it's described in the book also is basically we're going to understand it as sniffing is the process of grabbing some packets, scanning them. Spoofing is the process of now I have a packet, maybe I'm going to copy it, but I'm going to modify it. I'm going to modify the fields, etc. Now, for these exercises, they're very basic ones that we're going to take a look at. And the goal will be to learn how this can operate. We're going to look at C++. We're going to do some scripts, although usually I don't require C++ programming. So in that case, I've pretty much provided the solution, the code for you. So you just have to modify a few things. And then in Python, obviously, we will modify a little bit more because it's a lot easier for you guys to modify. Okay, so let's take a look at the files that are contained in here. So as you can see, I'm going to create 2 assignments. This is just from last year. It just copied them. I'll modify these later. But basically, you will have a homework assignment, which is doing the sniffing part in C++. And then you're going to have one which is doing pretty much the same. Well, not the same. The problems are a little bit different in Python with Scapy, which is the tool that we learned about last week. So there will be 2 homework assignments, which will be due on the same day, probably. Additionally, there's a link on sniffing. We're going to take a look at that. As you know, here's the manual in case you need something. And we're going to take a look at this sniffing and spoofing document. I believe this is the most up-to-date. So I'll double check on that. And then there's the Word document, and then there's these slides. Okay, so I'm just going to quickly click on these slides, kind of point out. Wow, and that looks pretty tiny. Okay, so just read through this, right? It goes over some basic stuff of security that you guys already know about. So definitely, security policies and all that. So I'm not going to repeat any of that. But definitely do read it. Okay, and then, as you can see, so read through that. It's a fairly long document, but definitely take a read through it. It'll define, it's basically a lot of the terminology, things like that. So make sure you've gone through it. All right, the next thing that's pretty important, let's take a look at basically, as I said, this class is very focused on problems. So we're gonna, it's very lab focused. So let's take a look at some of these lab related documents. So basically here, it just provides some information on what we're gonna do of the attached lab. So if you will, actually, no, I'm just gonna delete this document. I don't think provides any value for you. Yeah, so let me just get rid of that. All right, great. So now let's take a look at this one here, sniffing and spoofing. Document. And then if we look over here, this spoofing, I broke up the sniffing into one part, the spoofing into another part. Okay, so you can take a look at the documents here as well. And this is some code that you will be using. So it's already, this is actually for the spoofing part. It's basically 3 different ways of doing one of the tasks. So you can try out the different code. One is simpler than being simpler than the other. But let's start with sniffing here. So I just wanted to point out that the document is kind of similar. So let's start here with the PDF. Okay. Okay. So you can see this is the C version of this lab. Yeah, so we're actually going to do both. The reason being that this is the C version of the lab. And then I can add the other one. The one I have here. So I'm trying to make this in a way that is not a bit confusing. So if I click on this, this is spoofing new. But this one is actually sniffing and spoofing. So I just think I have the names kind of messed up. I know what I'm going to do. So let me do this. I'm going to go Seed Labs. And we're over here. So packet sniffing and spoofing, it should be this one. Yeah, packet sniffing and spoofing. Right, so it's the same one I have 206 to 2020. I think. Just for sanity, let me make sure that they're exactly the same. Okay, so I'm downloading this one. Okay, so now let's go to Brightspace. So what I'm trying to say is there's one lab, it's called Sniffing and Spoofing, but actually what I just want us to focus on the sniffing part this week, okay? But we have to do it in both scapy and C, okay? So really then, we're gonna go to this section, sniffing. And this is the old one, which is just a C++ stuff, if I look at it. Yeah. And so now I'm just going to add the new one. Okay. So in here, I'm just going to say upload files. It'll be downloads. Apparently has the same name. Yeah, hold on. Let me change the name. Downloads. Just going to call it new, basically. Okay. So I'm going to add it again. All right, so you should now see it, right? You should be seeing it. Also, I'm going to get rid of this thing because you can just get it from the website. All right, I will update these assignments, as I said, because it just now it seems to be copying from the previous semester. Okay, so sniffing, right? So this week, although these documents cover, let's say problems 1 through 7 are sniffing, problem 8 is spoofing, you need to understand, please, that we're only doing the sniffing part for this week, okay? But the sniffing, the problems that pertain to sniffing will be done in both C and in Python. This one, sniffing spoofing, is the questions for just C, C++. Okay, I don't know if I can rename this. I'm sure that I can do that. Okay, but, and then just know that sniffing, spoofing, new is the one that's basically Python, okay? And so it's interesting because the problems are not exactly the same. There's a little bit of overlap, but they're different and you'll be using two languages, okay? So let's start, I guess, with new first, and then we're gonna work our way into the C, C++ version. Okay, so this is the sniffing one, packet sniffing and spoofing lab, so as you saw. So let's just scan through the document first. Okay, talks a little bit about environment setup. Now I'll tell you, for most of these labs, really, although we could do it with multiple machines, we can also do it with just one machine. It's perfectly fine. This talks about Docker and how to do the setup. Usually though, we can do it with one machine, to be honest. Okay. Now, I've only tested these with VMware. That's the only thing. And now this semester and last semester, we've switched to VirtualBox. So we might have a few issues there, but we'll work it out. Okay. All of this information, as you notice in the new seed labs, has to do with Docker. So it's all this Docker stuff. So we'll have to figure that one out, or just convert your VM to VMware, and that should be pretty easy. So let's take a look at the tasks. Okay, so let's start there. So as you can see, basically, you have tasks such as using scapy to sniff and spoof packets. That's really going to be the goal, okay? So regardless of whether you're using a Linux machine, a Docker machine, or VMware machine, that's just configuration of the operating system. But what's important is solving the problem, showing evidence that they work, okay? So just brief overview. So we'll be using scapy to sniff and spoof. If you remember, I kind of did some of this on last week, okay? So I went over that. So there's an example of the code. There's an example of the code running, as you can see. And then we have some examples of how to sniff packets, okay? So I also went over this kind of last week. So we'll just elaborate a little bit more this week. Shows ways of running the code. And then here we have here we have some tasks. So these are actually, at the end of the day, the problems that you will have to solve. So for instance, you'll have to capture ICMP packets. You'll have to capture any TCP packet that comes from a particular IP and with a destination of port 23. You'll have to capture packets that come from or go to a particular subnet, such as this one. So you can pick any subnet, or you can pick a subnet that is already in your VM environment. So no need, for instance, to take your VM environment or your network environment and change it to this one, right? So that's not necessary. Instead, just replace that with your own. Okay, so that will be a little bit of the sniffing. Then we have spoofing ICMP packets. So we have some interesting problems that we will talk about. One in particular of a machine that is not there, right? So we'll take a look at that. And then you have this interesting trace route problem. Now, I've already kind of introduced that briefly last week. And then here we have a little bit more on it. So we'll discuss that one as well. And then a combination of sniffing and spoofing. Writing programs to sniff and spoof. So here we have a few other. And then this just provides some additional information on how to write your functions. But if you notice, the difference here is that this is using the pcat library. So because this uses the pcat library, this is in C++. So these problems, I will, you should read through this code, but I will kind of just focus this on very specific things that we will be doing. Okay. But we will do this sniffing passwords, spoofing, a few things. This will do this problem, the ICMP echo request and reply. So that should be a fun one. So I will lay out the problems in your document, which ones you have to do. You don't have to do necessarily everything in the document, okay? But definitely read through it. There's going to be some information. This provides information on the C++ and IP headers. As I said, I'm not going to require you to write C++ code, and I have provided that for you. Okay, and then, so that's the quick overview of this one. We will come back to this document to read through it and have a sense of what we need to do, but I just wanted to lay out. This is the new one, the new document. We're still going to do the old one because I've always liked that lab. And it's very similar. It's not outdated just because it's an old document. So let's take a look at the old one. And this is basically the old one. So you can see here, it's just more succinct, I like. So it's got it's got all these problems that I want you to answer, problems 1 through 5. So, and then you have the spoofing problem 6, 7, and 8, which you will do with C++. Okay, so for this document, this week, you are responsible for the first 1 through 5 problems, okay? And you will do this in C++. Then we've got the spoofing part, 6, 7, and 8. We are going to do this next week, okay? And it's actually, this is just one problem. Make sense?
Yes.
Okay, so this, that's what I'm, the way that we're gonna do it. Then the other one, the newer one, again, you're only going to do the sniffing part this week, and then you will do the spoofing part next week, okay? And I will, specify a little bit more when I create the Dropbox. All right, so hopefully that made sense, okay? Just because we have several documents, it's a little bit confusing, I guess. So now let's just pick one document and start with it, okay? So I usually like to start with the C++ one. So let's start with that one. And then let me look at this thing. Oh, okay, so I have done that. See, this document is also different. See, this one, I think is the same one, but it doesn't have the Docker detail in it, okay? So just for your reference, keep it, but keep in mind, they're literally the same one, okay? So glance through them. So this link and this one are very similar, and they're all kind of similar, but these two are almost an exact match. All right, so let's start with this one. Okay, pretty simple one. Packet sniffing and spoofing. Okay, so let's take a look. Let me make this big. All right, overview. So packet sniffing and spoofing are two important concepts in network security. They are two major threats in network communication. So being able to understand these two threats is essential for understanding security measures in networking. There are many packet sniffing and spoofing tools, such as Wireshark, TCP dump, networks, as you know. Some of these tools are widely used by security experts as well as by attackers. So being able to use these tools is important for students. But what is more important, and this is what I was saying, what is more important, because the thing is the tools change, right, over time. You know, now Wireshark, TCP, dump are popular. In the future, something else might be the popular thing, but the underlying way that it works probably will not change. Okay. So yeah, so what is more important for students in a network security course is to understand how these tools work, how packet sniffing and spoofing are implemented in software. Okay, and that's why we're going to take a look at the pcat library. Okay, which, as I said before, it is the underlying library for a lot of things, a lot of the firmware, even of firewalls and everything else. So the objective of this task is for students to master, or at least, you know, get a feel, I should say, the technologies underlying most of the sniffing and spoofing tools. Students will play with some simple sniffer and spoofing programs, read their source code, modify it, and eventually gain an in-depth understanding on the technical aspects of these programs. And at the end of the lab, students should be able to write their own sniffing and spoofing programs, certainly in Python, not so much in CS. I'm not going to focus too much on it. So the first set of tasks that you will be responsible for this week, 1 through 5, are as follows. So sniffer programs can be easily written using the pcat library. Okay, with pcat, the task of sniffers becomes invoking a simple sequence of procedures in the pcat library. At the end of the sequence, packets will be put in a buffer for further processing as soon as they are captured. All the details of packet capturing are handled by the pcat library. Tim Carstens has written a tutorial on how to use the pcat library to write a sniffer program. So I recommend that you guys read through this document if you want to learn more about the pcat library. Okay, so in this task, you need to read the tutorial, play with the program sniffx included in the tutorial, and read the source code sniffx.c and solve the following 5 problems. Okay, which is very similar to the other thing we're doing, but just in C, C++. So that what we need to do is we need to go to this website. Let's go ahead and do that. All right, and I don't know if you guys can see this. Yeah. All right, so read through this document over here. It provides a lot of this explanations of how it works. And then somewhere towards the end, you should find the, here it is, sniffx.c. Okay, so you will simply download this file, sniffx.c, and try it out. So in a second, when we go to the virtual machine, we'll do that, and I'll kind of play with that idea. But that should be pretty simple. Okay, so download this code. Then we're going to learn how to compile it and do everything that is required to run it and kind of start scanning information on the network directly using the libpcat library. Now, all the code is pretty much written, so you don't have to change much. All right, so now let's go back to the document. Oh, here. Okay, so once you've downloaded that program, Sniffex, and compiled it, then you need to answer the following problem. So the problem number 1, please use your own words to describe the sequence of the library calls that are essential for sniffer programs. This is meant to be a summary, not detailed explanation like the one in the tutorial. Number 2, why do you need the root privilege to run Sniffing? So this question I already answered, if you remember last week, but you know, make sure you answer it. Where does the program fail if executed without the root privilege? So think a little bit about that. So basically, you just have to answer it. There's no need to do anything here. Problem 3, please turn on and turn off the promiscuous mode in the sniffer program. All right. This is actually an important concept when you're sniffing traffic. So the question is, can you demonstrate the difference when this mode is on and off? Okay, so you'll have to figure out what's the difference when you do that in your ability to look at network traffic. So please describe how you demonstrate this. So this will be in your lab. Number 4, please write filter. And so this one now gets into, I'll show you in the code how we can do some of this. So number 4, please write filter expressions to capture each of the following. In your lab report, you need to include screen dumps to show the results of applying each of these filters. So basically, your goal will be to capture ICMP packets between 2 specific hosts. Okay, so you're gonna, just like we talked about last week or did last week, you have to have the sniffer running, and then you have to trigger the sniffer capturing the packets by actually doing the specific protocol. So for instance, if you wanted to generate port 80 packets, you can just open a browser, for instance. All right, then the next problem is capture TCP packets that have a destination port range from port 10 to port 100 and then trigger it. So that could be SSH, which is 22, Telnet, which is 23, port 80, which is web, and so on. Pretty simple, right? So that's all we're doing. Remember, this is under the concept of sniffing today. Number 5 is, please show how you can use Sniffex to capture the password when somebody is using Telnet on the network that you are monitoring. You may need to modify Sniffex a little bit for this to work. You also need to start Telnet server so that you can basically create packets with port 23, right? Destination port 23. If you're using the pre-built VM, then the command should be there to install Telnet and run it. So if you remember, Telnet is like SSH, right? Except that it is unencrypted. Basically, every letter is kind of sent one at a time, and because it's unencrypted, we should be able to capture and see the letters in the packets themselves. But you'll just have to figure that out. Okay. So that's the, these are the problems that pertain to C++, okay? So I'll create a link for these. This, on Thursday probably. Now, this part, spoofing, this we're gonna hold out for next week because this is, even though it's just one problem, it's a little bit more difficult, as you might imagine. This will require you to do both sniffing and spoofing together because we're gonna do a very interesting problem of, faking the existence of a computer machines or a computer. So for instance, you have you ping, for instance, 1.1.1.1 or 1.2.3.4. So in your network, that machine probably does not exist. The scenario is, how could you, via a code, provide replies, echo replies, when you ping that machine 1.2.3.4, for instance, okay? But that's spoofing, so make sure you understand that because you're creating fake packets in the network. That will be, we're gonna leave that for next week. Okay. Are there any questions about this part, guys? No questions? All right, so let's go ahead then to the VM, and we're just I'm gonna walk you through some of these ideas. So let me start. So I'm gonna focus right now, what I'm gonna do is just focusing on this one, right? So sniffing and spoofing with C++. Then we will come back to the other handout and look at the additional problems there. So let's start the virtual machine. All right, so I'm going to share. Yeah. Right. So you should be seeing the VM now. Okay. Let's give it a second. So we used a VM last week, I think. 454/2022. Here it is. Yeah, so we wrote actually some scripts. That's good. Okay, so first thing we want to do is we want to go to that link, right? So let's open up this. So we're in the seed lab, so probably seed labs here. Let's find, let me find it. Here it is, programming. So yeah, here it is. So you're seeing here the document that you need that I showed you before. And now we just have to go to the bottom. This is the sniffx.c code. So we're going to download it basically to your machine. Save the file. Okay, great. We've got it. And now we're going to go over to the downloads. There it is. I'm going to move this to the desktop. There we go. All right, so I'm going to go ahead now and open up a terminal. All right, so I'm going to do clear ls desktop ls cd its 454 clear ls. All right, so let's open up the file. So I'm going to do nano sniffx.c, and there it is. So this is our script that we're going to take a look at. As you can see, this, as I said, this is the main library. Pcat, there you see that. Right, and this is an underlying library for a lot of the tools out there, you know, like Wireshark, etc. So same concept. So this is in C, but the basic idea is that you can see these structures here. They represent the individual headers of a packet. So really a packet at the very low level is just treated as a buffer. You have a buffer and then you have pointers, and every pointer will point, you know, being defined as a pointer of this structure will point to just the necessary bytes for a specific header. And that way you can get the information. So that's really the gist of how libpcat works. So if I, for instance, go to the whiteboard, right, and if we take a look at the whiteboard here, we can see, right? So we treat a packet just as a buffer, and then we initialize all these pointers like Ethernet header and IP header, and they all have a specific structure which determines the size of them. Then we just say, okay, point to the, you know, where the Ethernet would start, and then we're going to point in the buffer IP and then TCP, and so on. Payload maybe, and so on. Okay, so this is the general idea of what's going on in the C code. Okay, so we initialize all these objects so that we can reference the information via those structures. So if we go back to the code now, you can see that. So every one of those structures will contain all these fields. So if you're ever wondering about the fields, you can always come here to kind of take a look at them for your purpose. So you can see an IP header is a TTL. We have destination and source IPs and so on. There's a few conversion functions here also for converting from string to integers and things like that. But you can see we've got sniff Ethernet, sniff IP, sniff TCP, and so on, right? And then we've got definitions for all the flags, etc. Few helper functions. Let's see that there. And then we've got a few main functions, which I will point out in a second. So we've got this function, gotPacket, is really one of the most important functions. We'll talk about it in a second. Okay. And we've got down here the main function. So this is the main in C. So if you notice here, go to the bottom. Right, so that's the end of it. So we have this important function called the pcat loop, which you're seeing there. So the pcat loop is basically similar in a sense to how we did this in Python and Scapy last week. So the pcat loop is just a function that's running in a loop, and it's capturing the packet. So it's got what is called a hook. It's hooked to the pipeline of the network in the kernel. And then now it's going to grab packets. And whenever it grabs a packet, it basically goes to gotPacket, this function over here. So if we can look at everything else here, it just initializes a lot of things that you can basically ignore. However, one important thing you're going to need is this one here. So if you notice, you have a buffer here called filter expression. If you notice filter expression, and it currently contains IP. So this is where you're going to put in your filter expressions very much like you would if you were using Wireshark. Okay, if you're using Wireshark, TCP and IP source, etc. Okay, so this is where you're going to change. So really, your main change is here. You don't have to change much of everything else. This one is important. It just says how long Sniffex will run. So basically here, it just captures 10 packets. And then you have a few other things that are described there about getting information about your device, getting the device itself, initializing everything, and then doing the scanning. Okay, so we've defined that we have a filter. We've defined that we have a loop that's running pcat loop. Whenever we capture something, we take a look at gotPacket. Okay, we take a look at gotPacket. So now if we go over here, we look at gotPacket, and basically gotPacket, if you notice, one of the parameters that it passes is this variable packet. That's literally your packet. Notice, it's a pointer to a buffer in memory that contains basically your packet data, right? All the headers. So then if you notice here, these are the different headers as I described them before: Ethernet, IP, TCP, payload. You're going to initialize all of these, okay? And then you're going to tie them to the buffer that you receive, okay? So notice here that is happening. You grab packet, that buffer, and now you're basically wrapping the pointers or making the pointers point to it. So you have Ethernet here, right? And then you just have a little offset. So you do packet plus size of Ethernet that moves in the buffer. And then now the pointer is IP. So because that's the IP part. And you just keep doing that for the rest. Now, here then, you're going to have some additional functions that, based on the protocol, what should you do? Remember that some packets will be TCP, some packets are ICMP or whatever. And so you have to really say, well, let's say you only have TCP packets, right? So you cannot, your problem can only look at, or your problem, sorry, is specific to TCP packets. Then, you need to go into this direction. And here you would need to define a function, okay? Your own function, for instance, let's say my firewall function, right? And so this firewall function would relate to dealing with that TCP packet. You would pass the packet itself to the function, and the function would do the processing for you. But it would only apply to TCP packets as they are different. So hopefully that makes sense. However, for now, that's not necessary. It's pretty simple, really. What we're going to be doing, it's really just a warm-up. So it should not be very difficult. Okay. All right, and that's basically it, right? So that's basically it. You have this approach. Notice here it continues with the payload. Notice the payload now, it is the original packet plus size of Ethernet plus size of IP plus size of TCP, so that you can create the entire offset and have your pointer to the payload. Payload is not something that we use that much in this in the first few weeks, although payload is quite important when you're looking at intrusion detection systems. Intrusion detection systems, if you remember, they have signatures basically, and about 50% of a lot of those are just payload based. Okay, so the contents of the payload. So certainly it's important, but it slows down the network quite a bit. So usually at a very low level, like hardware, firewalls, Cisco firewalls, you're not going to do much with payload. And that is it. Okay, so hopefully that description makes sense. Are there any questions about sniffx.c? Okay, I'm not hearing any questions. So now let's go ahead and let's start working through the problems. So let me control X. All right. All right, so I have my sniffx.c in there. The first thing, remember this is C++, so I'm going to have to compile this one. Okay, so right. All right, so first thing we want to do is we want to compile sniffx.c. So let's.
I do have one question.
Huh? I'm sorry.
So you said the lab is going to be C or Python, considering they're both the same documents.
They're not the same. There's different problems, but for this one, you have to do the 1 through 7 problems with Sniffex. So if I
with
go
this C file here.
Yes, with this C file.
Okay.
That's what I'm
Okay.
about to show you. So if you remember, let's go. So you should be seeing Brightspace, right?
Correct.
And Sniffing, right? And
Right.
so there's these 3 documents. These 2 are pretty much the same, but they're mainly Python. This one is pure C.
Okay.
This one is pure C. So what I can do, I couldn't change the name here. Let me download this. Change that name to C++, something like that. All right, so now I'm going to delete that one. All right, and now I'm going to add it. I renamed it. Up. So if we go back to table of contents and then scroll down, you can see here, I renamed it, right? Sniffing, spoofing, CC++. Got it?
Yeah, I see that. Thank you.
This is the document that I'm currently talking about, okay? This one. So as I said, this document actually includes sniffing and spoofing together, but I only want to focus on sniffing this week. Keep all that consistent. So because the spoofing ones are different kinds of problems. So, and this is a lot easier. So today I'm going through this document, and what I said was, what I'm demoing now is I've read through this. You need to answer problems 1 through 5 for this week. Okay, and so I'll create a link and I'll say from the sniffing and spoofing CC++ document, complete problems 1 through 5. Next week, I'll say from the sniffing and spoofing CC++, complete problem, basically 6, 7, and 8, task number 2, okay? And that'll be one link. I'll keep the links separate for sure. Okay, got it? All right, so we're about to do this now. We're about to do this document now. So the first thing we want to do before we run, so these questions, as I said, you can just answer on your own from your own understanding and discussion. But you have to do this. So we're going to basically write a filter expression to capture each of the following. So ICMP packets, TCP packets, and the telnet, you have to capture the password. Okay, so I'll kind of show a little bit of it, but obviously I want you guys to solve these. So let's go ahead back to the VM. All right, so you should be seeing now the virtual machine. All right, so I'm going to now compile this one. So it should be GCC sniffx.c dash lpcap, if I remember correctly, dash o sniffx. All right, so it compiled. Sometimes these things generate warnings, okay, as you can see there, but they're not necessarily errors. So let's go ahead and run this one, sniffx. And no permission. So that's one of the questions in your handout. So sudo.sniffx, and there it is. If you notice, the program is now running, okay? And what you want to do is you want to trigger this and capture some packets. So we can do, I can open another terminal. I'm going to ping 8.8, right? And if I look at my sniffx code, it is generating code. Notice it only captured 10 packets and it completed, whereas this one is still running. Make sense? Now, you might say, what's the reason for showing the C? Well, it's important because Python is very slow, right? So if you were to build your own solution in the network, it would be recommended that you actually write C code and not Python code, just because of the speed, the speed gain that you would have. So this is an important understanding, although it might be a little bit more difficult. All right, so how do you go about dealing with this now? So let's say that you want to change, you want to capture some packets, right? So you want to capture ICMP packets. Let's go over here. Now we're going to modify the code. So I'm going to go Nano Sniffex. So notice these were ICMP packets. Oops, what did I do? Oh, yeah. .c, correct? All right, so I'm going to hit sniffx.c. I scroll all the way down, and I'm going to ask you guys the following question. Why was I able to capture ICMP packets if my filter was IP? Shouldn't my filter have been ICMP? What do you guys think? Any thoughts? No one? So why does IP work?
Because it's a protocol?
Right, but IPs include ICMP packets, right? So it looks at that first. So there's Ethernet, IP, TCP. So TCP and ICMP are both IP packets. Do you see that?
Yes.
So that filter expression will work for that. Other things that you can do in your notation are things like ICMP, and then that would work too. You can say things like ICMP and then specify things like you can specify either host. So you can say host for an IP packet. You can say specify that you want a source host. What is this one looking at? It's looking, remember, always you should imagine that you're like this and you're looking at the packet that's going through. So this packet, I'm looking at it and I'm going to say, okay, this is an ICMP packet. This is also, I need to look at the source host, destination host, right? So the source host is this IP address. And so that's how you're going to understand how that should work. So for instance, you can say source host 192.168.1.20. Do you see that? So this is a way to write in the filter expression. So it's pretty easy that way. If you want to write destination instead of host, it's DST. You can also say source or destination, source and, that kind of thing. So you can play with that. Got it? So in those problems, you have to change this, okay? You will have to change the filter expression, and then you have to show evidence that you can capture the packets. For a range, it'll be something like port range. So you can say, for instance, source you can also say TCP source, and you can use keywords like port range, and then specify a range. So for instance, 200 to 300. And those are port numbers, okay? They're in the TCP header and they specify what you want, the service. So remember, port 80 is web, port 22 is SSH, and so on. So it would be a good idea to create a list of all the port numbers that you have available, okay? Now for the TC, let's close this. Clear. So if I want to do telnet, telnet seems to be installed over here, right? So then I'm going to do clear telnet 127.0.0.1. Right, and notice I am telnetting into the VM. Oh, I did that wrong. Clear. So seed. All right, and there you are. You are now, just like you do with SSH, you are now telnetted. This is important because, to steal the password, you need to use telnet, right? Because it's unencrypted. As you know, SSH is encrypted, and you would not be able to do that with a sniffer. But unless you break the cryptography first, okay? So this shows you how to telnet, which basically means that whenever you run, oh, and am I still telnet? Yeah. So when I'm gonna be clear here. So when you do this command, remember the underlying thing that's happening is that you're generating packets. Okay, you're generating packets in the background. So they will be packets that are TCP packets with destination port 23. Does that make sense? So that will generate the packet in question that you need. Now, when you need to capture the password, you will do pretty much what I did, right? So you do this. When you're typing this, you're typing seed. And when you type this, these packets are going to go in the network. Those are the ones that you will need to capture. All right, so you'll need to think of a filter expression for capturing those. And then you need to show to me that you have actually captured the packet in question. Are there any questions on this one? So that should be enough for you guys to solve this problem, I think. If we go back to the handout, that's problems 1, 2, and 3, 4, 5, right? All of the documents, sniffing and spoofing, CC++. All right, so I'm gonna go ahead now, actually, and create that link so that, since it's fresh in your mind. So let's see. Yeah, so I'm just gonna delete this because this is the old one. I actually don't know why it copied. It never did copy these before. All right, so now I'm gonna create the new assignment for this one. New assignment. Homework. Sniffing. CC++. There we go. So from the document, sniffing, I think it's sniffing and spoofing. CC++, complete tasks. Take a look at it. we're going to say 454. So it's this document. So complete problems or problems 1 through 5 of task 1. Basically, sniffing with Sniffex. That should be clear enough, I think. Any questions about this?
No questions.
Fair enough. All right, great. So today is the 18th, so that's the 20th. So this is going to be due the 27th by 10 p.m. and 16 to the 29th. All right, that's it. That's your homework is, your first task there. I said you're going to have 2 separate ones, but hopefully that's clear enough. All right. If there's no questions, now let's take a look at these 2 documents. All right. Oh yeah, okay. So now let's take a look at these 2 documents, and we're going to move now to the Python version of this and the problems associated there. Okay, so we're going to take a look. Let's start with this one, I guess. So you should be seeing this one. Okay. So this is the packet sniffing and spoofing again. This is basically what I had said before. Here we are going to cover, of course, packet sniffing and spoofing in Scapy itself. Okay, you can watch the chapters 15 for more information from the book. That'll provide some info. We're going to use the VM. I've already gone over a little bit of background on Python. And so these are some of the problems, okay, which I did last week. Some of the examples. So we install Scapy, so we all should have it. I did this exercise, right, where we imported all from Scapy, then we created a header, IP header, showed some of the fields, and you saw this. Okay, we made it executable as well. So that's been covered. If we want to sniff packets, we also did this. So we've got the sniff function. We provide a filter, very much like we did in C. And then we have a function that handles packets that are captured. And there it is, right? There it is. And that just provides the, we show the packet that we have captured. Okay. Now, what's important here is the problems that we're going to be doing for this one. So usually, so now notice I'm focusing on task this one, 1.1b, given that the rest you've kind of done. So usually when we sniff packets, we are only interested in certain types of packets. We can do that by setting filters in sniffing. Scapy's filter uses the Berkeley packet filter syntax, right? And you can find the BPF manual from the internet. So the problems these problems, you'll have to set the following filters and demonstrate your sniffer program again. You should set each filter separately. So here, pretty simple, similar to the C++ one, capture only ICMP packets. So remember, in the filter that I used, I had set it to IP, so I was actually capturing any packet that has a IP header. You have to put in ICMP specifically. Then also capture any TCP packet that comes from a particular IP and with a destination of port number 23. Notice that these problems appear to be similar. They're not, okay? And I'm gonna be very particular in this because they might have you should pay attention sometimes to destination or a source, or if it's a particular IP, etc. Okay. So read them carefully and make sure you get the right filter expressions for these. The next one is, for this problem, is capture packets that come from and go to a particular subnet. Okay, so you can pick any subnet such as this one or one that corresponds to your own virtual machine setup. Although here it says you should not pick the subnet that your VM is attached to, I'm changing that to just, actually make it whatever your machine is. I have no interest in you having to reset the whole network. Okay. Is this clear enough, guys, that you have to complete these three?
Yes.
All right. Now spoofing ICMP packets. This is for next week, as I said. Spoofing just means basically that you change the packets manually. Right. Here's an example of that. We also covered this last week. You put in the IP address here, for instance. Right, so that's been covered already. Now this problem you do have to complete, okay? Trace route. So this one, the only thing now all of this, and let me go back to that one, but all of this in lab task, anything in C, C++ that you see here, you can ignore because it's been covered in the other lab, okay? So you can definitely ignore everything in here that's related to C, C++. So these, you only need to focus on the Python part of this, okay? So let me just take a look at one thing. Okay, so for the sniffing with scapy, right, so you'll capture ICMP packets. You'll capture those TCP packets for port 23 with a specific IP. And you will, capture the packets that come from a specific subnet. Right, so that's it. So I'm gonna keep it simple like that, these two assignments. So basically then, just everything else is for you to read, but just task 1.1b. What I'm gonna do is the trace route problem, I'm going to save this one for next week because it doesn't, if you look, I was thinking about it, since, you know, we're doing something like 1, 2, 3, 4, technically this is spoofing. We're modifying some things of the packet. So then you're only responsible for this. That's it. Do you see that? So let me go into the handout now. So task 1.1b. Let me go. So let's create that assignment as well. And as you can see, that should be pretty easy. From this one, sniffing, right? So I'm gonna delete this one because this is from last year. I'm gonna create, what is it, task? Just wanna remember. Task 1.1b. Assignments. Let's call this one sniffing. Sniffing with, or just sniffing Python. This will also be due because it's being assigned on the 20th. So this will be due on the 27th by 10 p.m. All right. So from the document, sniffing, complete task 1.1b, all 3 problems. I.e. Sniff, ICMP, Sniff, telnet basically with IP and Sniff. What was the last one?
Subnet.
Subnet. Perfect. You're all paying attention. Good. All right. So yeah, that's it. So from the document sniffing, complete task 1.1b, all 3 problems, i.e. Sniff ICMP, Sniff telnet with IP, and Sniff a subnet. So that's basically the assignment. And hopefully this is clear enough. Okay. All right. So I'm going to save this one. And so you should know now what you need to do. So now let's go to table of contents. And now let's take a look at this new document that we just downloaded today. Apparently it was updated. So let's take a look to see if there's any interesting problem in here that we can also want to do. I don't know if you guys have looked at it. Let me know if you found anything interesting in there. So this is all the same description. This is for 2004. So this just relates to, let's see. There are 2 sets of tasks in this lab. The first set focuses on using tools to conduct packet sniffing and spoofing. It only requires a little bit of Python program, a few lines of code. Okay. The second set of tasks is assigned primarily for computer science engineering students. Students need to write their own C programs from scratch. This way they can gain a deeper understanding. Solid, yeah, you definitely, for coding in that pcat library, it's not trivial. Now here is, in this lab, we will use 3 machines that are connected to the same LAN. We can either use 3 VMs or 3 containers. Figure 1 depicts the lab environment set up using containers. We will do all the attacks on the attacker containers while using the other containers as the user machines. So here, usually it's a LAN network. That's the network ID, and you have these machines, attacker host A and host B. Now you can probably just have multiple VMs on VMware. I believe VirtualBox should support that, but here this provides the Docker option. I know you guys really like Docker last semester, so you can, if you want, follow the Docker approach as well. I have no real, I don't think there's any, you can literally just use one machine and a lot of these things work also. But take a look at that if you want to configure Docker. So some stuff to read there. Now let's, so that's, again, as I said, if you want to use Docker, I thought there was something on cloud, but it seems like it's all Docker. So now let's take a look at the problems, which is really what I'm interested in. So let's see. This is the same one that we used. Same one. Notice here it's got some differences. But I don't think, so here just notice there's some code on providing interfaces. So this is probably relevant to the Docker setup. Yeah, so just pay attention to that if you're using that. Okay, then we have here. Yeah, we've already done that. We've already talked about that. All right, so here's the problems again. 11B, capture ICMP, capture any TCP packets. 423, we talked about that, and the subnet. So they're basically the same. Then this is spoofing. Okay, so we've talked about how that works. But that's going to be next week anyway. We'll come back to this next week. I don't want to mix both things.
Did you say we have a supplied file for Python to sniff with?
Did you see the class on Thursday last week? We went over that.
Yes, I did. I have those files.
Yeah. So
okay.
You have to use those, right? So I actually provide, so your starter code for that is actually, so let me switch to the VM. I think we did this. You guys remind me, but I thought we did. You guys, are you guys seeing the VM?
Yes. Okay.
So if we go in here, ITS 454, spring 2022, ls-l. So we did plain sniffer, right? That should have been the one.
Correct.
So Nano. So this is a plain sniffer. You basically run this, you tell it to sniff for something. So let's try ICMP. And then we just show the packet, right? So I'm gonna run the script. Oh. Python 3. It's list, oh, wait. Oh yeah, the permission, right? There. Go. All right, it's listening on the network. Seems I have another terminal. Okay, I'm gonna do ping again. And it's capturing packets. Do you see that?
Yes, I didn't realize that this that last week's files that we used tie into this lab.
Yeah, so if you think about it, so at the end of the day, let's go back to the handout then. Let's go back to the handout. So I was just going over this one, right? I just did the first one, capture only the ICMP packet. Do you see that? I literally just did that.
Yes.
But now the other one, capture any TCP packets that come from a particular IP and a destination port number 23. You'll have to write the filter expression for that. And you will also have to write you'll have to trigger this with telnet, which I showed also today. I just didn't do that particular thing, but you'll have to do it. And then capture with a subnet, you'll have to come up with that filter expression. So that one I'm not giving you. You'll have to figure it out. Got it?
Yes, that makes sense. Thank you.
Yeah, that's it. I mean, you know, this second assignment is not that difficult. My plan on Thursday is to go over a little bit more the H.D. Moore case. So remember, you have an H.D. Moore case, do that night. I still want you guys to solve as much as possible of it, so be ready, but I will provide a little bit more information on that one on Thursday. And then otherwise, you'll work on these two labs, okay? All right, so the other thing I was, because as Joshua pointed out, there's a new lab. And so I was just going through it. I actually forgot now which one I was looking at. So give me a second. Let's switch over to Brightspace. All right, so let's go to the contents. Sniffing, right? So this is where we are. I've created the two assignments. They're tied to this one and this one. Also, you're going to read this on your own. So now let's just take a look at this. I just want to see if there's any interesting problems in here. But we've pretty much established that this new lab, all that's different about it is that it goes over how to do this with the Docker containers. So for those of you interested in that, do it. And then, like I said, this code we had looked at. This is the code that I just showed that pretty much helps you to do everything. These are the three problems. No difference there. This is just spoofing. We'll cover that, a little bit more of that next week. Trace route. I'm saving this problem for next week because it's a little bit harder. And I want you to do the H.D. Moore first, because this also has some ideas in there. Okay, and then this one, sniffing and then spoofing. This is also a spoofing, so this will be saved for next week. So in this task, you will combine the sniffing and spoofing techniques to implement the following. So you need two VMs, ping an IPX, which will create an echo request. If X is alive, the ping program will receive an echo reply. So what we want is when a program that whenever it sees an ICMP echo request, regardless of what the target IP address is, your program should immediately send out an echo reply, which is what I had said. We're going to fake a machine. So if you ping 1, 2, 3, 4, it doesn't exist, right? But we're going to create a program that replies. That is spoofing. So we're going to save that one for next week. That's a fun one. And we will do this in C and also in Python, just that in C, I've already provided the code for you guys. Okay, so you'll take a look at that. And then here, oh, and then anything to do with C again, you can ignore. Because as I said, that's why I always have that little other lab, the first one I covered today, to cover all the C stuff, and then this you can disregard. It's pretty much the same thing. Yeah, this we've covered. That's the same things. capture ICMP packets between two hosts, capture TCP packets in the port range, sniffing the password. Totally did this. Telnet, please show how you can, your sniffer program can capture the password when somebody is using Telnet. So that's the same. And then this spoofing one, it's in C, so just ignore that. Again, this is been covered. In this task, you will combine the sniffing and spoofing techniques to implement. Yeah. All right, so there's no new problems in this document. Thanks, Josh. I mean, worth looking, but as you guys have seen, there's nothing new. The only thing that's new is if you want to configure Docker, then it's got that information. If you want it, just get it then from the Seed Labs, okay? I'm going to delete that document because it can create some confusion. All right, so I'm gonna delete that one, which is this one. So really what I care for is the problems, right? And both documents have the same set of problems. And so we're fine. And then as I said, if you want the Docker configuration information, just get that the latest one from the Seed Labs website. And that's it. So that hopefully I think is the tasks for this week. Are there any questions? Was there anything that was not clear, guys?
I don't think so.
All right, makes sense, right? All right, so that's the plan then. You can start working through these. You can work on them also on Thursday. Also on Thursday, we'll go back to the Ph.D. Moore lab and just work through that one. Has anyone at this point solved that problem?
I think I just about have it, I think.
You think you just about have it? All right, great, excellent, good work. All right, so maybe you can demo it a little bit before. Yeah, so maybe you guys can demo it a little bit, whoever feel, and then we'll talk a little bit through it. Show you maybe a little bit of more code on Thursday, but it should be fun. It's a fun problem. And that's it. So that's it for this week. These are the sniffing problems. Next week, as I said, we will tackle the other ones that I mentioned, like the trace route and that ICMP one. But you know, that's for next week. So I'll stop the recording now. So just go ahead.